So I wanted to do some more KiCad videos, but I didn't think that I had, really anything going on terribly too interesting. But then I thought about it a little bit different way. I have at least, well, I've got one interesting board coming up, but I think about 3 different breakout boards that I need to make. And I thought that they'd actually be kind of good to show for anybody that's, just getting into this or just review sake, right? So it's not a whole hell of a lot of schematic. It's not a lot of components. It's really just what I'm saying, a breakout board. What I've got is, and what you're looking at here is, this is a flight control board right here. And for the heavy lifter in this case, we're using one that we use right off the freestyle drones. But I want to have it control it, but I want to be able to take it away because it's not like the little 5 inches 6 inches that you can just grab and stick on your computer. The thing's huge, so I can't, if I want to program it, I have either got to cut, disconnect, or whatever, a whole lot of crap, or bring laptops out to the vehicle to be able to program it. So what I'm going to do is, we thought briefly about, why don't we just solder wires onto here, and we'll put disconnects onto each one of those, and you just unplug it. And I thought, man, that's kind of tedious and crazy. So why don't I just make a board, make a as big as the cheap board houses will make it. So with Seed Studios, 100 by 100. This is about 40 by 40, so we'll be able to fit that nicely in the middle. That's kind of what you're seeing down here. It was just, you don't, of course, on the schematic have to do this. It was just trying to get my mind straight. And I'm going to take all these pins off of here, so we'll solder them onto here, onto a pad, onto the big PCB now, which will go out here to where we're seeing, signal outputs. Those will be something more like screw terminals. So then it'll be a lot easier to just, grab a screwdriver and just put the wire in, screw down, or vice versa if you want to take it out and go program it. Still, not click and everything comes apart, but a hell of a lot easier than desoldering. So I think that'll be good. Also, it'll give us a lot better place to mount a lot of stuff too. So this little baby flight control board here on this big, in this big giant area, it didn't look so good. I guess we could have dealt with it, but this will work out better. So inside, when this is done, say this is the PCB, it'll be large. 100 millimeters. We'll have some holes in the corners here. We'll probably throw some shock mount on there too. It's probably not necessary, really, is it? Anyways, we'll mount it down to the box base that we've got all this stuff in, and then we can add on all the rest of it easy enough. So what I've got here is just a bunch of 1x1 connectors. So I'll kind of show you. They're buried down in here. You could use whatever you want, and as a matter of fact, I didn't even really need to do a schematic for this. When you do breakout boards, if you want to, you can just run the traces in PCB new. I've done that a bunch. This, I just kind of wanted to have this here to kind of help me get my thoughts together, so I could decide, let's see, do I want, what do I need here? At one point I'm just grabbing, the board here and going, let's see, we've got the camera ins and outs, we got the telemetries for these, we got the extra, got motor, ESCs. Oh yeah, we don't need the ESCs. Incidentally, I don't need the ESCs because we're powering those from a different source. And then start connecting things. So it works out a little bit easier, I feel. So right here is the one I chose, connector 1x1 male, right there. Right? You could make up one, do whatever you want. Now the motor signals, I still feel this might be an okay idea, because see, I could have, this right here, these are a 4-pin. So this is a 4-pin connector that I just dropped in here. And of course, these are those single-pin connectors. Now I could have made these all be a 4-pin connector, but I was thinking that if I put them out here on the edges, again, not necessary in the schematic, but I could put them out here, it would help me understand, this is all for motor 1, this is for motor 2, etc., whatever. Again, it didn't turn out to be necessary, but I thought that would help. And then also when it comes to the PCB, the association to the PCB footprints, I think that it would be better to have each one of these separate, because then when I do physically make the PCB, maybe it will be better to take the motor signals from each one and just run a little jumper wire off to here. Say this was the PCB. From here to there, from here to here, from here to here, you know, just a short one, rather than say one from this one looping over here to a row of 4 that you have already defined. I think that would be a little bit cleaner. So anyways, that was kind of my thought process there. Well, I kind of figured I'm going to make my own little pad for this anyways, but I thought I'd take a look. And so you kind of click through your connector pin, look at, oh, whoops, didn't mean to hit that. Go here, well, there's one, but it's through hole. No, I don't want that. Is there a pin? No, right? There's probably one in here that kind of would work, but it's got too many words on it. Terminal block. Now the terminal block we'll use for the output one. So we got that. That's probably going to be fine. But I can't find, you know, test points. These were some here. Let's see. I thought maybe I could try maybe one of these. This could be okay, but you see it's got a lot of extra stuff around it. Maybe I don't want that, you know? So we'll go ahead and we'll make our own. So we'll close this, and then we're going to come up here to Footprint Editor. You're going to choose your library again as usual. Then give it a name. So this first one, I think I'll just do a single pad. So what should we call this? Single pad. Okay, I don't really know how I'm going to make this quite yet. What size? Probably something like I said, like maybe 2 by 2 or so. So I hit this, pop that right there, hit edit. We'll make this SMD, make it, come on, make it rectangular. You know, I think maybe like this. Do I care about the X and the Y? Yeah, let's go with that. I think I'll put that as the default right there. Make sure that that is invisible for later. And this reference, sure. Now since we need another one that is 4 by 4, how about we take this and we'll move it over a couple. Look at your grid up here, so we're 1 millimeter apart. So if I put this one here and I put another one, say, over there, this is 1, 2, 3, 4 millimeters apart. So that's quite a bit. Definitely, you know, easy, but I think we could get away with moving it over a little bit like that. And so then we'll Control D for duplicate. So I click on it, Control D, bring it over. There's those. Now remember, you're going to need to come in here and change all these. Well, that's 1, so that's good. 2, so that our numbers on our schematic symbol will associate properly to these. Okay. And let's change this to, that'll change in a second anyways. That's a dumb name, but whatever, we'll let it be. And then now we're going to save it again. But when you pick save here, just give it a new name. Okay, it's a 4 pad. I'm not being real creative today. So that's it. Now we've got those 2 saved. We can close out of this. And then when we go to associate this, we should have our single pad and our 4 pad. Maybe I should have called that 1 pad. So it puts it all together with it. Anyways, let's see, motor signal. We've got 4 of those, so that's going to be the single pad. associate those. The camera, the inputs, those are going to be the 4 pads. Input, 4 pad, 4 pad. Okay. Now the motor output cam, all these outputs here are going to be the screw terminal. So I think we can find one of those in the terminal block library. And I already found one under the Wago ones that are probably okay. They're a 5mm pin pitch. So in order to do this properly, like I've been talking about in the other videos, before I take a wild guess, okay, it's not so much a wild guess, but before I just grab one of these and associate it, I probably should go to DigiKey and take a look at the terminal blocks and see which one I want to use. I'm thinking that since all of these wires that will be coming out going somewhere are on the order of like 30 gauge, we could probably get away with going with, let's see, something a little bit tighter. So these ones here, this is the value right here. That's the pin pitch. I think I found it under here. Yeah. No, wait. No, those are too many pins. No, here we go. So hit that. Take a look here. And you see, so this has got a 0.1 inch, 2.54mm separation. That's pretty good. And the block looks okay, you know? So I think it's fine. I might choose to redo it in other situations. Maybe, you know, I might want to redo it, but let's call this good for right now. And then we'll go take a look at DigiKey. So I'm doing this again kind of backwards. I'm saying, yeah, that's probably going to be it because I know it's going to be easy enough to change it if I want to. We'll associate it now, get this part done, and then we'll flip over to DigiKey and I'll see what I can find for a terminal block for this. So there's the output there. There's the camera output. Oh, don't lose track. Okay. Then that's everything all associated. Make sure you apply and save down at the bottom. Hit OK. Then we're good to go. So as far as boards go, this is probably, you know, one of the easiest. Well, let's see. We'll run our electrical rules check here. Run. Yep, they're all good. Close that. And then let's generate our net list. Put it right in the current one. Okay. Let's go here and open up the PCB and read the net list. Okay, so I flip over to edge cuts, and this is what I find is handy. Look down here at your coordinate system. So we see our X and Y right here, but then you see the DX and DY there. If I go and I grab my line tool, and then my grid, let's change it to 1mm increments. Now if I zoom in here, you see how we snap to the increments, and that's good. Right here where I'm at, look down here at the bottom. So it's 110 by 70. That's where the X and Y is right now. And the DX, DY is the same. Okay. Now, if I hit spacebar, the DX and DY will go to 0. And then when I move around, everything's relative to that point. Okay. So now that's how I can find the 100 by 100 with this. Okay. Incidentally, if you're looking at, I think the footprints default to this. I made comment of this in one video back there that I was wondering what the hell was going on. Well, this is what's going on. You hit this, and down here now your X and Y are done in radius fashion here, you see? So get rid of that for now. Okay, so let's get back over to the corner we want. If it's not 0 by 0, I'll hit spacebar again. That zeroes it out. I'll click. There's my line. And I'm going to bring it down until it is 100. Right there. And scooch over there. Okay, so 0 on the DX, but 100 on the DY. And continue on. Hit escape at the end there to clip off the little bit. Now, I like to round the edges. I know it's an aesthetic thing. You do not have to do that. But after I get the whole thing defined, then I come in here with a radius and decide how far back I want it to be. And so maybe 1, 2, 3, 4, 5. That might be kind of big. Let's see what that looks like. Oops, wrong way. Always the wrong friggin' way. 1, 2, 3, 4, 5. Okay, so you see? You do that, and then that's going to be the corner of the board. Oops. So then I'll go here, do the same to the other edge. 1, 2, 3, 4, 5. Let's see if I can get it. There, right. You'd think. Counterclockwise. Counterclockwise. 1, 2, 3, 4, 5. Click. Boom. Here. And then just to kind of shorten this, and then I'll just cut to the end here. I go through, I do this, and then you can either hover over and delete or hit your trash can. Get rid of the line. Get rid of the line that's there. And then you draw a new one that just goes from the end of your radius, since it doesn't have, as far as I've seen, a trim feature for this, because it's not really high on the, graphic CAD kind of stuff. It's not high on their list here. Oh, piss, come on. There we go. It escaped. You see? So I'll go around, I'll round the other corners here, delete the lines, and then I'll have a board with a 5mm radius. Be right back. First, I'm going to add in some mount coils right here. So what I did is I go over here to footprints, and you click, and this is the one I already had, but normally you just go select by browser and scroll through, and then somewhere in here you'll find something that says mount coils. And I know they change the libraries all the time, so look for something similar. I'm going to use 3mm fasteners into standoffs, pretty typical. So that's what I went with right here, not a pad, just a 3mm hole. And then you go ahead and double click that, and then you can place it, you see. So you can add footprints without having to have a schematic that has an association to everything, right? Have it wired everywhere. Now, I want to have these in a proper location, so it's kind of hard to move these things around properly. So let's see here. Let's grab this. And it should be right in the center, so you want to kind of figure out a way to, count back and place it so it ends up being in the right location. So there's that. Now the other way to do it, so that you could end up making some holes later, if you're going to measure this out, or maybe you're going to run the board that I'm mounting this to on the CNC, maybe I'm going to drill all the holes for all the things, right? You kind of want to know what this actually is. And also the 40-ish or so, square in the center here that the flight control board's going to be at. I want to know that as well, along with the the ones we're using as a standard issue, 30mm hole distance. So the first thing I'm going to do is do some layout lines. 100 by 100 makes things pretty easy, because you can see here we've got the bold lines every so often, every centimeter. But what you want to do is you want to find your 0 point again. This is down here in the corner of the DXDY, right? So that, as long as you didn't hit spacebar along the way, that'll still be there. If not, put it there, hit spacebar. Bring it over, and then we get to 50. See that down there? So you give it a click. And you could even draw this above, up here, if you like, because this is just going to be a guideline. So bring it down here to 50. What I mean is you don't want to get it too tied up with stuff here so that it becomes hard to delete later. Same thing over here. This one probably, yeah, that's 50 by 50. Okay. Then you can kind of keep going around here. Now you've got something to measure off of if you like. Then, different from when we were making footprints in previous videos, if you get over the top of the thing and you edit it, I can't just exactly change the position, because this is based on, the corner way up over there, the actual document origin. So I don't think there's any real easy way to do that. So here's what I have been doing so far. I need to make this, well, first is just a want. I would like this to be in the corner with enough edge margin to where I feel like it's going to be okay. There's not any real force on this, but I don't want to stick the whole right smack up against the edge. Okay, so there's our box there, and yes, this is edge cuts, but it doesn't matter because we're going to get rid of it anyways. The idea here was that you just draw your square out. So now I know that this is 100 by 100, and I need, for the board it's going to mount to, I need an 80 millimeter box. I need 4 holes 80 millimeters apart. Now, I come here and I can grab this guy, and I can snap him right to the center. It should be, the footprint should have its origin right in center, but in one of the fairly recent videos, we're messing around with changing origin on some of these, so be careful that when you go to move this, that you're actually right in the center. Okay, now I am going to duplicate that, Control D, put it right over here, put it right over here. So that solves that problem. Now the one in here, we got to do the same thing, but we have to go 30 and 30. So it's got to be 30 by 30. And then probably before I go too far down the road, yeah, let's go ahead and get rid of these lines here. There we go. Keep these ones here, and let's grab the whole lot of those and just move them over here for the time being. Again, this is 100 by 100, and we've got nice little marks here, so we can tell that, you know, 30 is going to be 15 this way, 15 this way, etc., right? But we'll go ahead and draw the marks. Now, origin right here, it says 50 by 50 down here, so get right to the center, hit spacebar, that zeroes that out. Now we can come up 10. There's our 15. And if you want, just click and come over. There's our 15. Then continue around and making the box. Okay, then we'll duplicate this. Oops. There we go. So that is kind of, you know, our guideline of sorts. You know, when we start to orient these things, we need to keep them within these certain boundary lines here. Also, probably want to be mindful of the fact that the board itself actually comes out to here, which we might go ahead and go to silk screen and draw that square on there. But we'll just have to know that the pads that we put for these to go to, you probably want to put them out here or so rather than right here. That's going to make life a bit difficult. Well, I've been staring at it for a little while, and I'm trying to think about, you know, where I'm going to put the rest of the components. It really doesn't probably matter a whole hell of a lot, but it's worth a little bit of, you know, forethought, I guess. So here is, again, the board, and it's going to be sitting right there like so. And if I were to wire, say, the cam to one of these cam pads down here, then I probably want to have it right up here. So I think that that's probably an okay thing to do. So we'll probably take our cam input. Probably should have labeled the other side, but I think you can get it from there. So I'll put the cam input right here. I'll put the receiver right here. Down here is the VTX. Same thing down there. And again, we didn't make one for the LEDs or anything. And then the individual motors, we'll do the same thing. We'll just maybe right next to it or inward or something. We'll space them out a little bit, something like that. But the motors, they won't be in on each side because your motor signal wires are right here and here, here and here. So we'll put those pads where they belong. That part's okay. So then the output, I think, well, should I just line them all up at the front? Should I put them on the side? What's going to matter? Well, right here is the USB. If I'm going to be programming it, I think it probably, see, good for thinking, that this right here, if I line a bunch of screw terminal blocks right here, it's going to be pretty difficult to get the USB to plug into the side of that. So this side will be no. Over here seems okay. The bottom down here, we're going to have the power cable running out of. So that's no good. And I'm not going to wire the power cable into the board and out of the board to somewhere else. I just want straight power out of that for right now. I think. I have to actually, you know what? I'm going to dwell on that a little bit more because we do not need big battery power in this. We just need whatever the max one out here. I think, yeah, down here, the VTX is 9 volts. So if I can just manage to get 9 volts into this, even just with a linear regulator, maybe I can tap that off of the big power. We'll think about that. Right now, we've just been going with plugging in a Forest battery just for just to get it going. So it's kind of looking like these are either going to go on the side or on the top. The camera will be coming out the top. Let's put them up on the top. Then I guess I'll just start moving things around. I'll put camera. Should there be any rhyme or reason to this? Should I have, so the motor signal wires, should I go camera, VTX receiver, Should I put this in the middle? Yeah, I can't think of any real big reason to put them in any particular order. Nah. Not for now, at least. So we'll put, click, grab. So the camera will hang out about over here. Oh yeah, this might be a reason. So I don't have to get things too wangled around here. Then the receiver goes about over there. Nothing perfectly aligned yet, right? And then the VTX is down here. Then all the individuals where they need to go. Okay, so I'm gonna have to figure out which one's which here. Oh, I hate you. Okay, there we go. So here's the thing. I don't like these J2, J3, J5, and J4. That's yucky. Don't like that. So I'm going to go back over to a schema here and make this make a little bit more sense. So right here, J2, look around here. So all these ones up here, J8, 9, 6, 8, 7, whoa. Yep, okay, here's what I'm going to do. I'm going to take this one here, I'm going to edit this, and I'm going to make it be M1. How about that? M1. No. Yes, that works. Forget the whole square thing about as far as like which one goes to which motor. I'm going to make that be okay in the PCB. I just want 1 to match with 1, 2 to match with 2, M2, and 3 is this guy over here, M3, and M4. Okay, now I have to save this and then run the netlist again, generate the netlist, hit that, come back over to PCB new, read the netlist again, and we'll exchange footprints if we need to. Yeah, let's go for it. And one thing I didn't do when I first started this was I didn't look down here for anything red, but we're good. Oh, let's try that again. There. Okay, see that? Delete extra footprints. I had the extra ones in there. Didn't like that. See, now we've got M1, M2. Oh, too many clicks. And see that? God damn it! I hate. It was better the old way. So we've got M1, M2, M3, M4 going right to the right pins, and that should be very clear coming out of that as well. We'll add some text, of course, on this after we're done. By the way, it's nice to read from the outside, right? So we're going to make sure that we scoot these in far enough that we could write all the text right along here that we need to have so that people know which one this goes to. Maybe up on the top right here, maybe we'll flip, this around. Oh, it won't let me, will it? Okay. Well, we'll get it flipped around here, so you could read it from the other direction, and then maybe pin numbers will be along that way, something like that. Okay, now looking at your flight control board, bring the picture back over here. The way they do this is motor 1 is here. It's like a backwards N. So you've got M1, M2, M3, and M4. This is the way that it is. So I'll go ahead and grab that one, and I will move it down here somewhere. And I'll grab M3 and bring it down here as well. Something like that. Okay, so that's kind of the idea. Where'd my holes go? Oh, what the butt? Okay, a little bit of a snafu there. So I had this, the idea was to get these little guys out here renamed. But when I reread the net list and said delete any extra footprints, it gets rid of my holes here. It considers those extra footprints. Damn it. So, I don't know if there's a way to do that without screwing it up. See, watch. See? No more damn holes. God damn it. And I can't undo it. So what you have to do is don't save. Whatever you do, don't save. Just close it, exit without save, go get your other one, and then you'll be good to go. All right, well, I got to figure out how to do this a little bit differently, which just means I'm going to have to grab this, I have to grab that, move that over here, and then I'll say rerun the net list. Actually, you know what the easy way to do? Just delete those. And then rerun the net list. Now we're good. Okay, well, that was a pain in the ass, but anyways, we'll get back here pretty quickly. So we'll just grab this, move it about over here. Be back in a sec. All right, well, I'm going to go ahead and save that there. And I'll shift some of this crap around and I'll get back to you. I want to make sure again that these are outside of the boundary. This is going to be too short of a line, so I'm going to get them kind of out here a little bit. But I still want to have enough room with these so that I can write all the words that I need to up there. Well, here's what I got so far. I decided to move them off to the side. It's not really that far over. This will give, basically it started from this down here. I want to have the power wire come out like this. Then that way it won't interfere with any of these wires. Well, if I move them out to here, and since I'm moving these out to here and these out to here, then let's move these out and match. And so they're all even and equal, okay? Then the next thing I want to do is I want to start writing some traces. But if you used edge cuts like I did, it's not a big deal. Again, I don't really care because it's easy enough to change, but I thought I would show you this. If I go ahead and I start doing this, I say, okay, I'm going to run this line from here to here and up to, oh man, it won't let me go across because it knows that that's an edge cut. So if you don't want to get rid of it yet, because I might need this center line here, what you can do, just get in here, double click it, and then change it from there to your front silk screen. And now it's just a silk screen line, which if I was thinking I would have made it that way to begin with. You see? Then I can take a wire, I can run it up to here, go get there however I want to. So I figure I'll just start over here, pick a spot, I guess, and start wiring the thing in. I kind of take a look at which one's going to be the most complicated to get in and around. This one here, I might have to shoot around here to come in or pop underneath. I feel like I don't want to deviate too much from a path for any of the motor lines here, any of the signal lines. I would rather not pop through a via, up through a via, around a corner, down, around. I want to try to stay on the top layer with this if I can. And I'm also going to try a new thing that I haven't done before, which I don't really need to do, but it's kind of a reason to play with it, to try creating, oh, here we go, a tune track length. So it's not a differential pair, but I want to try to make all the motor wires the same, just because I was thinking that this one here is quite a bit further away than this one, and maybe that might mean something. Again, it probably doesn't, but it's a reason for me to play around with the tool. Okay, this is pretty cool. So I already did it. What you want to probably do is, let's see what this first one is here. So watch this. Bear with, this is going to take a little bit. So I pick this one here, and I am going to run this one. We'll run this way around the outside. Oh boy. Okay. So run this over here. I guess this will work out reasonably okay. All right. So now this one I can tell you is going to be too long. We're going to have to make some adjustments. I want all of them to be as long as this. So you go here to route and you say route tune track length, and this has to do with this down here. It appears. So the microwave toolbar. So you'll see how this is relevant here in a second. So if I zoom in and I click on this, it's going to tell me it's too long. It's 161 millimeters out of, and it should be 100. Well, what you're going to do, I guess I could, yeah, go back here again. And you right click, and now you have these different options here. So you say length tuning settings. There's all this here, which we'll deal with in a second. I just want to make the target length, how about 180, just in case. Okay, so 180. I could have shortened that up. I might. Let's go with this for now. So then I come in here and I say, let's tune this track. And it says the track is too short. It should be 180. And look what happens. So you just bring this down, and there, if you've looked around on PCBs, there's this familiar little scribble that you get whenever they're trying to do this to get even length lines and or with differential pairs. So I click, and now I'm done. And I've got this. So now I have an exactly 180 millimeter long line here. Now, of course, this is going to create, maybe some other problems on its own, some inductance. Maybe I'm making a little antenna right there. But now I do have a line that's just the length that I need it to be. So then let's see what we can do with this long one. And here's my thought. I haven't done this one yet. I need to get to here, so I don't want to get terribly too in the way of this one here. So I want to stay over on this half. Yeah. So I go over here. Oh. Come on, dude. There you go. Oh, wacko. Okay, then let's try tuning that one. Too short. There we go. So that worked okay. So now those two lines are exactly the same length. Not real happy about that, but we'll let that go. So then we'll come back. We'll do another one. And I think we can probably get enough scribbles in here. Let's try it. That works. That's a pretty long scribble. I have to do some research on that to see, you know, what's the problems with that. Now, if I want to, remember, I can come here and I can go to the settings, and this is where this is for. So the max amplitude here, the max, you know, scribble is going to be so much. So you could adjust this as need be. I think I'll go with that. This will start from this side. Yes. Now I know where I need to go. Come down here. There. And that should be okay to pick right in here. Oh, yeah, well, there we go. And that's it. So now I've got 4 mortar lines that are exactly 180 millimeters long. Then we'll just run the rest of them. Shouldn't be too big of a deal. As long as I can get the thing to go the way I want it to. God damn it. Change the grid down. Let's go to 0.25. That should get it there. There. Oh, come on, you flippin' thing. God. It used to do better. This is no good. This is bad. This is badder. So I guess that's it for the routing. Now, the next thing to do probably is, let's see, I got to put some labels on this. But if I'm feeling confident that this is the way I want to go with it, which again, don't really care terribly too much, I can always make another one, then I'm going to flood it. So we'll add a filled zone. Start up, change my grid back because I had it in stupidness. There we go. So go here. And this is going to be the front copper. And, oh, interesting. We don't have a ground. We have no ground. We got to do some labeling. All right, well, here's what I want to do. I want to define a ground pin for all of these. And I'm trying to make this kind of simple and not have to do too much work, but I think this will maybe work okay. We'll just put in a ground flag here, and I'm going to pick, how about number 2 here on each one of these lines to be, this is kind of goofy, but it'll work. So this 2 is going to be ground, and so that will get known as the ground net, and, oh well, here. Oops. Right? Add that here and get it right on there. Okay, so then that will get me a pad that has a net name of ground, GND. So when I go to do a flooded front and back, I can make that all be ground. And my hope is that will make it a little bit more resistant to any kind of signal influence. Now, are these going to be the little pads that they are? Let's see. So this is the little pad. So we get little pad, ground, ground. Do I need to have a bigger ground pad on there somewhere? Maybe we can just add that in now over in the PCB editor. So I'm going to take this, I'll save it, and I'll generate the net list again. Oh boy. Okay. And then go back to PCB new. and read it again, and hopefully here I'm going to make sure that's saved. So if it doesn't, you know, before you do something stupid, save it, and then if you do something stupid in like my last situation where I can't undo it, then you can just close it without saving. So read the net list. I'm not going to say delete the footprints. Change. Let's just go for it. Okay, here we go. No red. Close. Everything's still there, and good. So now it shows these actually as being ground and they're connected together, so that will work. And then down here as well. Okay. All right, well that should be okay, and these here that are unconnected should just get connected when I flood this. So let's give this a shot. So zoom in here. There's our net. Happy, happy. Hit OK. There we go. And then right in here, those got flooded in. Nice. Nice. That I could have got one in there, but that's all right. Good. So then we'll do the same thing for the back, and then we'll riddle it with vias here to connect to the front to the back really well. All right, then what I'm going to do is I'm going to put a bunch of vias around the whole perimeter if I can. It's not going to get in there because of that. That's okay. We can live with that. And honestly, it probably doesn't matter anyways. This is, again, more just for the fun of it, I guess. So we're going to add a via, but I want to be kind of mindful of where I'm placing it. So I'll put it right, like right in that corner. There you go. So now watch this. So this is a neat little trick. So with this, the via, that's pretty new. I think that came out in 5 or something. Now I can right click on this and I can say create an array. And this was exactly what I was looking for, to create piles and piles of via stitchings. Yeah. I'm going to take this, I will make that be 1. The vertical count is going to be, how about 60, and we can delete some of them if we got too many of them. And vertical spacing 5 millimeters seems okay. So we hit okay, and look. Boom, 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 boom. Whole row of little vias right there, and oh my god, yeah, that was quite a bit too many. The last thing that I'm doing here is, as you can see right here, I'm adding the text to the pads and copying it up to here to the respective output. And I am also hiding a lot of this stuff that I don't need. So you can see, like right here, the J1, I'll go here, double click on it and say invisible. That J1, I don't need that either. Now, if this was, you know, resistors or any other kind of component, then it's kind of nice to know which one you're putting there, but these are all just the 4-pin terminal blocks, so I don't care. I'm also moving down this, this is from the chip on the fab layer here, and I'm putting it on the front silk screen. Since it's a good name, I had no reason to make another one. So yeah, we'll just do the same thing for that. All right, and then the J10, this is, so what I've been doing is I hid the front and back copper. So you can see this is the receiver. Get rid of that. And then this value will hide that. And then come over here and duplicate that so I don't have to redo all that work. All that. All right. Power ground, we know that's going to be the same because we decided on that, right? And then for the receiver, which one do we want to be which, right? It doesn't matter. We've got probably in order of most importance, I guess. So right here is going to be our S bus. And then this one here, let's scoot him out a little bit. This one will be for telemetry. So we'll just say telephone, whatever. We'll put that there. And again, scoot, I don't know, something like that. Now take all of this, duplicate that, and then I'll just stick it up here. But you see it doesn't line quite right, so no big deal. We'll just grab this, this, and this, and we'll move the whole lot over. Then I'll just grab this and this, move them over. Just that one, move that one. Right? So I'll continue doing this, and I'll be right back. So that's it. It's done. There are all the labels. Cleaned up everything I didn't need to have, you know, made invisible. That will be okay because that's on the silk screen layer. We won't see all the rest. I added this in here. This is 4 LEDs, resistor form all to kind of backlight the board. That's just a deal that I do kind of frequently. And that's it. So I think it's ready to ship out. Now, a few things that we learned along the way, or, you know, that maybe you learned along the way. The mounting holes. So if you want to create that, that's actually a structure you can add in. You don't need to add it in your schematic. And stitching vias through the use of creating arrays. So that was a good thing. And this was cool. I never got a chance to use this before, but this is the tune track lengths. And that helps you get multiple signal tracks exactly the same length. So I hope you found something helpful in that. This was kind of just a short little board, small little board that I needed to get done. And I thought I would just go through the process with all of you guys just to show you what I'm doing.